Hi, and welcome to the iteration of bits. Today we're going to tackle ripple effects in Godot 3. This is not as straightforward as they may seem, so prepare for a bumpy ride of a tutorial. The files for the final results can be found in the video description. To keep things concise, I will only be showing how to create the effect, not the entire project shown here. The first step is to create the supporting geometry for the effect. Start by adding a mesh instance node to the projectile, and then selecting a quad as the mesh type. Then add a material to the mesh. Select Billboard. Check Billboard Keep Scale. Set it to Additive Blending. And select our ripple texture. I will be using this one, but any fuzzy donut shape should do the job. Next, add an animation player node, and make an animation of our quad growing in size and fading out. To do the fade out, simply animate the color values on our mesh instance's spatial material. Because we selected additive blending, the material's brightness effectively works as its alpha value. With the animation complete, we can now create the script to despawn the projectiles and play the effect. Here I set the HP of the projectile to 3 and subtract it by the delta. This effectively counts down in seconds, giving the projectiles a lifetime of 3 seconds. When the HP runs out, hide the visuals and play the animation. Then after another second, remove the projectile from the scene altogether. The effect is showing, but it appears flickery and doesn't animate right. This is happening because all the projectiles are sharing the same material resource. To fix this, simply set the material as a duplicate of itself in the projectile's ready function. This will make the material unique and not shared with any other instances. Now the effect animates as we expected it to. The next step is to actually create the ripple effect. Godot's spatial material system has a built-in refraction feature. While this will create the rippling we want, it has some limitations. First, it doesn't work with billboard materials, so you must make the quad face the player with the script instead. Even then, the borders of the quad are clearly visible, even with all the specular settings turned down. Enabling unshaded would fix this, but refraction doesn't work with unshaded materials either. At this point, we have done all we can with Godot's built-in spatial shader, and we must dive into the shader code. So, select the mesh instance in the inspector, right-click on the material listing, and in the drop-down, select Convert to Shader Material. This will give us the shader code for what would have been that spatial material. We can use this as the basis for making changes. Opening the shader up, go ahead and add Unshaded to the list of render modes, and make a new line setting the albedo to the screen texture using the screen UVs. This will effectively make our quad invisible as it's just rendering what's on the screen where it already is on the screen, ignoring its own coordinates. Then to do a basic distortion, we add the screen UVs by the gray values of our fuzzy donut texture, which we access using the texture function, and the inputs being our texture and the quad's UVs. Then we multiply it by the refraction value so we can adjust how strong the result is. With a little fine-tuning later, it's starting to look pretty good. But there is an issue. Godot's screen texture shader input samples the screen, but it does so before transparent objects render, so anything transparent will not show up in our refraction. This is why the quad borders are clearly visible when we shoot near this glass pane, and also why the glass barrels don't show up in the refraction. We are going to need another approach. Fortunately, Godot has another method for sampling the screen. Viewport nodes have a function to extract their texture as a viewport texture object. The viewport textures contain the full render of what's in the viewport, transparencies and all. Additionally, the root node of all Godot projects is a viewport. So let's try pulling from that. First, create a new uniform in our shader to input the texture into. Then add a line to the ready function of our projectile to assign that shader uniform to the root viewport's texture object. The initial result has issues, for a couple reasons. Assigning the root viewport's texture to a sprite quickly shows that there is something wrong. That artifacting is likely caused by trying to read and write from the root viewport at the same time. If we change the first two nodes in our project to a viewport container and another viewport, we avoid the artifacting altogether. Note, don't change in the code what viewport we pulled the texture from. We are still pulling from the root viewport. Just the presence of the second viewport fixes the artifacting. Pulling from the second viewport will return a black texture unless we enable transparent background. I don't know why. Additionally, because the viewport texture renders the final frame, we are also going to be re-rendering ripples on top of the previous frame's ripples, so our effects are going to stack. It also renders the texture twice as bright as it's supposed to. To mitigate these issues, first multiply the code we put in albedo by itself. This will counteract the viewport texture being too bright. As for stacking, there isn't a clean solution, but there are ways to help. First, by setting the alpha for quads to the ripple texture, we can also counteract parts that get blown out by setting any pixels that get too bright to transparent. The result is starting to look better, but what about the hard edges on the ground? This can be counteracted with proximity fade. Here I create a new spatial material, set it up with the values I want, convert it to a shader material, and copy the code from there back into my ripple shader. Then I can use proximity fade with my ripples. Another thing that can be done is to improve the method of distortion. Currently, the distortion just offsets the pixels in a diagonal direction based on how bright the refraction texture is. What we can do instead is offset the sampling by how far away the pixels are from the center of our quad, and then multiply that offset by the refraction texture brightness. It's looking better now, but there are still rendering issues with the glass. Fortunately, these are not sampling artifacts this time, but just the quad physically passing through the glass pane, and Godot's renderer being confused with transparent objects that are really close together. This can be easily fixed by setting the depth pass to disabled. Our ripples are now, for the most part, complete. To flesh out the effect, I add an omni light that flashes, and a particle emitter that spits out some smoke when the explosion happens. And that is how you create ripple effects in Godot 3. It's not straightforward, but it does work. If you have any comments, feel free to leave one below. In the description, you can also find links to the project files and the Discord channel. I plan to upload more tutorials soon, along with devlogs of my current projects. And of course, feel free to like and subscribe to the channel. With that, I'm Huddy, and I'll see you next time at the Iteration Abyss.